sources of what are the sources of EM waves? So what it's telling is like, if a charged particle accelerates, it will produce a EM wave. If a charged particle accelerates, it will produce EM wave. So the first one, it's accelerating charged particle. An accelerating charged particle produces an EM wave. So what is this? Let's go back. We know something. If a charged particle is at rest, what it does, it can produce electric field. No? And if a charged particle moves, if it's having uniform motion, it will produce magnetic field. If a charged particle accelerates, it will produce EM waves. So where do you have seen like a if a charged particle is at rest, I'll just wanted to give some clarity on what I'm discussing. So we know the electric field at this point. And if a charged particle moves with a velocity at a distance y, so what is the magnetic field here? So the magnetic field is given by mu naught charge is qv by 4 pi r square, and the angle between them, let it be sine theta. Let me take some arbitrary pointer, y only. Theta is angle between them. Is it okay? No. So if a charged particle is having uniform motion, as it produces a magnetic field. If a charged particle is that, it produces here, what is this field? Static field. Statical field. What is this field? Static magnetic field. What is telling an EM waves, or better say, or propagating electric kind magnetic field. What Maxwell is talking is not about this E or this B. A propagating electric and magnetic field. So nothing but that is calling electromagnetic wave. So we have a background. This is from the electrostatics, as a static field is produced by a charge. If charge is in motion, if it's having uniform motion, it produces magnetic field. If a charge accelerates, then it will produce electromagnetic field. It must produce electromagnetic field. And what is that EM wave? It's a propagating electric and magnetic field, or a dynamic electric and magnetic fields. So they will propagate. How they propagate is on their own. And he proposed a wave equation also. Then next question comes how do that will generate and how do it propagate here? So let's take example of generation of that particular thing. So I'll take a AC source. I'll adjust to a certain frequency. Just wait. I'm at the beginning only. I had to talk so many things. Okay, there's a copper rod. I'll switch on AC source. It is as good as it is similar to like this. Now, what do you expect here? What do you expect here? So some AC signal this is. What do you expect at this point? Nothing, no? Sir, open circuit, no current will flow. Will I agree on AC source open circuit is there. It's having a resistance. The wire is having a resistance. Okay, I'll put resistance. Okay, some of you are asking resistance. Okay, what about here? That this wire will have a resistance, everything. Okay, no. Now, what do you expect here? So no current. Am I right, all of you? What is the use of this no current open circuit? Okay, in fact, there is a user. At lower frequencies, nothing will happen. Let me make the frequency what? Let me say some 500, or so like, let me take some 50 kilohertz, 5000 kilohertz. So what is this frequency of this? Not like 20, that one. Let me go for some 2 megahertz, this frequency. So what will happen? See, the electron doesn't know that there's open circuit. No. So what electron will do? The moment you switch on, this end will become positive, negative. So what the electron will start propagating. The electron will propagate like this. To conserve charge, here open the electron will start propagating from here. Don't say no jump, nothing. So what this electron will do? This electron, what's happened, will start. It doesn't know there is an open circuit. Am I right? Say like you are going, suddenly bridge got cut. So what when the moment you start journey, will you dream that, oh, okay, some bridge got cut? Nothing, no? So you're going to start your journey. You don't know there's some bridge got cut and the road, what happened, got cut due to some rain, something, whatever that one. You don't know anything. You are just going to proceed your journey, no? The same thing happens for electron. The electron will continue journey. The moment it comes, when it comes here, what will happen? It sees open circuit, it cannot make a jump. What will happen? And what is the state of this electron? This speed is having a speed. So it was having contingency. With that contingency, it is moving. Suddenly it encounters some open circuit. It cannot flow. So what will happen to contingency of this electron? Will get converted into electromagnetic wave. So here what we get is an electromagnetic wave will get it. It's a slightly new thing for you. Sir, open circuit, you only said that nothing will happen. Okay, at low frequencies, nothing will happen if you go for higher frequencies. So here we are getting a wave and it starts propagating like a similar to sound wave. So this particular copper rod, what happened, will behave like an antenna and there's a AC source. Means continuously open. This cycle will repeat continuously, no? This cycle will repeat continuously. The cycle will repeat. So first what happens, the electrons, okay, this end is positive. Let's say on that. So the electrons will move here and the electrons will move here. Okay, clear this one. Then the positive off cycle will get over. Then negative off cycle, this will become negative, this will be positive. So what all electrons it received, no, it will send it back. And what all electrons is generated, it will collect it back. So like that, what happened? I will adjust the length. The length matters a lot. Let's not go for designing of antenna. So here, in fact, I had to show a current is flowing. This is the beauty of this particular diagram. So you should not say like, hey, sir, like this is too much. Like you are showing current open circuit. As in fact, there'll be current. Because rate of flow of charge should be constant current. Then sir, where energy will go? The resistance of these wires will be very small. Let's not bother. So what all the energy of the source continuously, where it will go? Convert into EM wave. So here what we see, an EM wave. This was the Earth's experiment. Later on what happened? Jagdish Chandra Bose and Marconi what happened? They designed and they have shown, okay, in fact, there is a EM waves and they are able to propagate. They kept a detector from far away from this and they saw deflection. So what is this? This is an EM wave. Propagating, I should say like this, propagating EM wave. How you can say, I have a detector, I'll detect it. With this, I can say that I'll keep some detector far away. So there what I am able to get that EM wave. So who is generating this one? I'll switch off this. The detector will not show. I'll increase the amplitude. The detector again will detect large amplitude signal. If I decrease the amplitude, it will detect. So in this development, the detector, with the help of detector, I'm able to check that in fact there's a EM waves. So once again, I'm putting that the electron don't know that there is an open gap. So it will just go there. So the kinetic energy of that suddenly will be retarded. So that will get converted into electromagnetic energy, that one. So like this sequence will continue. So like this continuously EM wave will be generated. From where this energy will come? The source. So we need a source, no? So therefore that was the Gauss law. You see Maxwell so intelligent. Where is the source for that electric field? Charge will produce that, the source. I'm not saying that the source is having a energy, no? And that energy will be given to charge. Due to propagation of charge, there'll be electric field. Okay, clear this? Okay, till here, no problem. Next again. No. How come it will propagate? So let's assume that electric field is there. So what type of electric field will produce here? Varying electric field. The varying electric field produce magnetic field. Again, the varying magnetic field produce electric field. So like that, Alpine, they will reciprocate each other. And like that, the energy will propagate. This need not to move. This is fixed here. I'm not going to move this one. The system is fixed. This rod and source, AC source is fixed here. And I see that the energy starts propagating. Okay, sir, here energy will come, I agree. Because here the energy of source will convert into EM wave. How do it propagate? For this open, the Maxwell took help of these two. A varying electric field produces magnetic field. A varying magnetic field produces electric field. They reciprocate each other. And how do they propagate? So for that open, he has proposed like this. Propagating electric magnetic field. You may find wave a little bit difficult. Propagating electric and magnetic fields. Okay, I'll show this one. It will be. I'm drawing the plane electromagnetic wave. Means it is a polarized one. In fact, we should show non-polarized. Non-polarized is very difficult. So therefore, I'm showing the. Okay, what is this curve? This represents E bar. Okay, no. What about the B bar? I think in Google you can type it. No, it will show the diagram. Google propagation of electric magnetic fields. No, I think in Wikipedia it is there. It will show the diagram. You do watch. Really worth that one. How that antenna will produce. Now, if this is the electric field blue color. No, so shall I say that this originally the source where this antenna is kept, we'll call this everything set up as antenna. So what is antenna? Converts electrical energy into EM wave. Okay, there's everything. Go give a good name for him. Antenna, copper rod, some small connecting wires, and the AC source of high frequency. I'll call that as antenna. So that antenna is kept here. So what actually everyone thinks that, okay, here's some energy, okay, no problem. But how come that energy will be far away? So somewhere like a far away here. This is what like a point P, I'll write it. Far point. How much? 1 kilometer, 10 kilometer, 100 kilometer, 10,000 kilometer, or you can put even 1 lakh kilometer. I'll see that EM wave is present. Okay, here electric magnetic field is there. How come it will propagate? Maxwell's equation. What is telling? This varying electric field, what it does, it will produce a magnetic field here. So who is responsible for this magnetic field here? So some. They should sleep, no? They should lie in. See that the arrow should point towards the z-axis only. In that way, you have to draw it. Okay, the books, what he said. So Maxwell, he said that this is E bar. This is BZ. So since it is pointing along Z axis all the time, red color, no? Yeah, BZ, this is EY. So what is the expression for EY? EY is equal to E naught sine kx minus omega. What direction? They're propagating with the speed of light. And what about BZ? B naught sine. It will be directed along Z axis. It will be directed along Z axis bank field and will be propagating along X axis. E bar will be always directed along Y axis, will be directed. This is a plane transverse wave. And how E bar and B bar at all points will be perpendicular. And what is the phase difference between them? 0. EY and BZ will be in phase, will be like a propagation vector. Shall we call this as like this equation represents a traveling wave? Okay, now let's come to the the most beautiful part of this. This arrows will be a little bit difficult for me to explain. So I'll just put it in a simplified one because I want to explain that Maxwell's equation. So I'll take in. So we'll break up. Now the E bar, here shall we put it? E1, EY, I'll put it. Initially, these two are existing. This varying EY, what you do, it will produce B1Z. And now it should be directed along Z axis. This varying magnetic field here will produce E1Y. Continuously from here, the energy will be coming. So continuously the energy will be coming. So what happened? Continuously EY will produce, BZ will be produced. Will I agree this? So this EY will produce B1Z here. And this BZ will produce E1Y. How it is possible? The laws. Varying electric field produces magnetic field. Varying magnetic field produces electric field. Got the idea? This is how did it propagate? Next question comes. This one. Okay, next after this again. So this varying magnetic field. This varying magnetic field. So what it does? It will produce a magnetic field here. So E2Y. I'll give color so that it will be easy for everyone. BZ. So this will be B1Z. Parallel to that axis. B2Z. Let's get into the expression part. We will produce this E1y, this BZ, will produce this B1Z. This EY, how it propagates. See, you have to give explanation. Next, Maxwell open, you have to give explanation. The wave propagate. Don't say that sir, electric field propagate. How electric field propagate? Will it have any legs, sir, so that it will do running? No, nothing like that. So this EY, what happen? Varying electric field will produce magnetic field here. This varying magnetic field will produce this E1y. This E1y next will produce B2Z. This B1Z will produce E2y. So like that, the source for E2y is O, B1Z. The source for B1Z is what? E1y. Now the source for E1y is BZ. The source for B2Z is E1y. So this, you have to put it like this. Huh? This one, this one, this one. So like this will happen, the continuously, so this will produce, no, this particular field. This will produce this field. This field will produce this field. This will produce this field. So like that will happen. Don't say that, shall I say this energy has now come here. Sir, what happens here? Again, the source will pump that energy. The source will push the energy. So that it has come here. So like that, continuously what happens? The propagation occurs here. And what is the equation for the propagation? Traveling wave. And this was the EM wave is what the Maxwell proposed here. And how they will be when they're propagating, the direction of propagation will be perpendicular to the direction of electric and magnetic field. And always they'll be mutually perpendicular. EY and BZ will be in phase at all times. And okay, I think I'm able to convince everyone here. It's not just I wrote some mathematics equation. I'm just giving enough proof for you. This one. So shall we call this as a source? Source that continuously generates energy at origin. So as the source is on continuously open, we can see the propagation of EM wave. Okay, got this idea? This was the Maxwell, he has to take care of this one. I think it's not that easy, no? In 18, I think 67, 64 something he has proposed here. So he has to really fight for this. There was no problem for him. Faraday's law, this is. Gauss law. Gauss law for magnetism. This is what Ampere circuit law. He has to struggle a lot. I think around some 30 years he has spent. So what is the reason? How it can be different? Finally, what when he was able to break through it, and this was the Maxwell's equation, and he was able to give all the mathematical proof. Everything got justified. And later, what happened? They started demonstrating as in fact EM waves they propagate. Different. And from there is what we have now. What we have modern communication, telecommunication. What we say no, because of EM waves only. Where all we are transmitting the EM waves in the optical fiber, in the cable TV. We'll agree now. Internet. Most of us we are taking internet. No Wi-Fi router. What is the source? This EM wave only, sir. The EM wave will propagate in air and also will propagate in coaxial cable and also will propagate in some tube. Waveguides it has called as. It has really revolutionized that one. I know what we see, television, everything, no, all this mobile, internet, everything is because of this EM wave. I think whom we should thank, the Maxwell definitely. And next Marconi and JC Chandra Bose, because they have practically designed equipment and demonstrated it. Yes, in fact, EM waves can be generated and they propagate also. Okay, this was the basic idea of the generation, everything. So when displacement current is the main question that will come from EM waves. Next again, what is the frequency of EM wave? This omega. What is this omega? From where this omega? Omega is what? Omega of source. Omega equal to 2 pi f. And with what speed the EM waves will propagate? With the speed of light. The EM waves. Speed of light in vacuum. Now, even in vacuum, they propagate S. So shall we say that EM waves are EM waves doesn't need any material medium for propagation. You look at the sound wave. It needs medium, no? It needs atmosphere. You look at the wave propagating on a rope. It needs a medium. What about EM wave? In vacuum also. Electric field, can it exist in vacuum? Fine, it will exist. Magnetic field, can it exist in vacuum? Yes. So therefore, now what will happen? This EM wave, can it propagate in medium? So still, we had a background what? Only mechanical wave. We never thought it's a non-mechanical wave. So what some scientists, they thought is some sort of medium. They call that as the ether. Not your chemistry liquid ether. They thought like some sort of ether is there. Some material, invisible, will not have a taste, will not have even inertia. Such a medium, in fact, that is what supporting this EM wave. Again, the experiments went and finally what happened? Michelson-Morley experiment. So initially they proposed almost for 20 years, they thought there must be some different. Later on in the Michelson-Morley experiment, from that they conclude there's nothing called like a ether. There's no metal, there's nothing called like a metal medium called as the ether. That one. So then finally it's concluded that as even in a space, it can, the Maxwell just proposed it. That one. Later on they clarified there's nothing called like a ether, that one. So shall I say EM waves, what they are? Non-mechanical waves. Doesn't require medium. You know, does not need any metal medium for propagation. So therefore, they are non-mechanical waves. Then we went for some wave equations, no? Like this again. If I differentiate with respect to this, we'll get a wave equation. So we'll write the wave equation. So finally, d square, this d square e by dt dx square should be equal to mu naught epsilon naught d square. Differentiate this with respect to, I think here, let me take with respect to x here. Oh, no problem, let it be. Okay, so sorry, it should be x. Propagation along x-axis we took it, no? Yeah. Not along y and z. X is the propagation, the direction here. So like this, when they are related here, this one. So these are the wave equations. So it is satisfying that one. So from the development, we are able to predict that. In fact, if I compare this with a standard wave equation, so in place of c, what shall I get it here? 1 by c square will come. So comparing with the standard wave equation, what we get is c equal to 1 by mu naught epsilon naught. So this is what the Maxwell proposed. This is something what we are relating. We are bringing relationship between speed of light, magnetic medium, and electrostatic medium. Mu naught is not ordinary thing. Absolute permeability, epsilon naught. Relative, so like absolute permittivity. So they're related. What about in any other medium? This is in free space. In any medium, it will be V equal to C that one. So this should become equal to 1 by mu into epsilon, or this will become 1 by mu naught mu r so finally this will become C by, so what is this speed of EM wave? In many material medium. Okay, so like this, finally what happened, he was able to say that all these conditions. Okay, now, sir, how do that? One more small way of thinking that will really help you a lot. So I just brought one equation, like how this B naught and E naught are related. One more equation, I'll bring it. So I'll proceed like this. We know electric field is equal to dq by, from Coulomb's law, and the magnetic field from Bayes-Savart law, I dl by 4 pi r square. Let me divide these two. B by E, mu naught I dl, 4 pi r square get cancelled. So this will get this as dq by epsilon naught. So mu naught epsilon naught I dl by dq. What is I? I should be dq by dt. This dl, you can write it as some dr. Let's make it generalized here. Dr by dq. No? So dq get cancelled. So mu naught epsilon naught dr by dt. What is that dr by dt? Should be the speed of the wave. Should be the speed of the wave. And further, what is mu naught by epsilon naught should be? C is equal to 1 by under root of this one. So mu naught should be 1 by c square. And in fact, this particular in free space, what is the speed of the wave? Equal to c. What is v? V stand for speed of the wave. Okay, therefore, so what I can write it? B by E is equal to 1 by c square into c. So therefore, BC is equal to E. And what is B? Magnetic field at any instant of time. So this can be also write B naught C equal to E naught. So where all, there's a one relationship. So like this, we are trying to relate the speed of light with magnetic and electric field. I think there's a historic thing. We had a relation between B and E, but something we brought that one. This is what the Maxwell did. You can say definitely an historical thing, that one. So we are introducing that the speed of light is related to, in fact, magnetic field, electric field. So now there's a lot of things is there. Electric field, can it manifest itself into light? Yes. Magnetic field, can it manifest itself into this one? Yes. Even the light, speed of light we say, can it be of this one? So later on, what when the scientists even they went for light. So what is the EM wave? Propagate with the speed of light. So the light also is made up of electric and magnetic field. Later on we concluded here with experiments. These are some best thing. I think this will be very easy for you to remember. BC before Christ equal to E. Don't remember like B by E. You'll get confused. Before Christ is equal to E. Easy to remember things. So like this, all the some terms are related here. I'll continue tomorrow from here. Okay, just have a thinking on this one. Analyze all these things. So tomorrow we'll continue from here. I'll end up the class.